Now then, I appreciate I am probably killing you with the theory by now, but I mean it. I really want you to understand Kubernetes networking. Because when things stop working and the brown stuff hits the fan, you really need to have your stuff together. Yeah? You really need to have your stuff together. Anyway, look, last bit of theory, right? When you create a service, it gets this unique, long-lived IP. Cool, we know that. But I don't know if you noticed, that IP is actually not on any network that you recognize. So it's not on the node network and it's not on the pod network. It's actually on this third network that we call the service network. Only you know what? You're going to love this. It's not really an actual network. Maybe calling it a network might be more appropriate. Because no matter how much digging you do with your normal networking tools, you are not going to find any interfaces on it. And you know what? There's no routes to it either. So, you'd be right to ask, well, how the heck does traffic even get to it then? Aha! It goes like this. Every node on the network has this process running called kubeproxy. Actually, it's running on the cluster as a daemon set, so you get one kubeproxy pod on every node. Anyway, one of its main jobs is to write a bunch of IPVS or IP tables rules on each node that basically say, any requests that you see addressed to this service network, rewrite the headers and send them to the appropriate pods on the pod network. And then, obviously, there's routes and stuff to the pod network. So, let's step back a second, right? A flow might look like this. We've got some nodes here with these IPs and we've got this pod network. This is a service, and look, the IP is not on the pod network or the node network. Anyway, the pod sends traffic to the service. DNS does its magic, right, and it spits out the service IP. So, the pod then sends packets to its virtual Ethernet interface, which has abso-freaking-lutely no idea about the service network. So, normal networking etiquette applies, and the interface sends the packets to its default gateway. This happens to be a Linux bridge called CBR0. Now, if you know your Docker, actually, it's the equivalent of Docker 0, but Kubernetes names it CBR0 for Custom Bridge 0. Anyway, it's a dumb bridge, so it sends the packets upstream again, this time to the node's ETH0 interface. Now then, to get there, the packets get processed by the kernel on the host. And when this happens, the kernel says, hang on a second, I've got some IPVS or IP tables rules for stuff with this address. And it applies a rule, which pretty much says something along the lines of, anytime you see a packet for this address, rewrite the destination address to this on the pod network and send it on. And that's effectively it. Now, we don't want to get into the weeds too much, but there's a few ways to actually implement all of this. And since Kubernetes 1.2, running kubeproxy in IP tables mode has been the default. And it's fine and all good, at least until you get to proper scale. You see, at its core, IP tables is a packet filtering technology for firewalling. And in Kubernetes, we're kind of shoehorning it into being more of a load balancer, and it just doesn't scale at that. So, there's a new mode that we call IPVS mode, and as the name suggests, it uses the native IPVS in the Linux kernel, which, to be honest, has always been intended as more of a load balancer anyway. So it scales better than IP tables at this. Like, it uses hashes and the likes to be faster and more scalable. Plus, you know what? It supports a load more load balancing algorithms. So, in IPVS mode, round robin's the default. But under the hood, it can also do least connection, source hashing, destination hashing, shortest expected delay, and more. Anyway, look, kubeproxy in IPVS mode has been stable since Kubernetes 1.11, and it's going to be the default going forward. But we're getting into the weeds here, right? For all intents and purposes, what we've shown you is how it works. And that, ladies, gents, and cloud gurus, is the end of the networking theory. Way! Okay, time for a quick demo before we do a summary.